In this video, we're going to prove the triangle angle sum theorem. Let's get started. We're given a triangle ABC with angles marked as shown. Our goal is to prove that angle 1 plus angle 2 plus angle 3, or the sum of the angles in the triangle, total 180 degrees. The first part of our proof, as always, will be the given. We are given triangle ABC. The next part of the proof will be a little bit different. Because of an assumption that Euclid made for Euclidean geometry on the flat plane, when you have a line like AB and a point not on the line like point C, there exists only one line through the point C that is parallel to line AB. So we're going to create that line. Both blue lines are parallel. Line AB was given as part of the shape. We created the line C, let's say here D. So we're going to say that AB is parallel to CD, and the reason we know this is true and this is doable, we're able to make such a line, is by Euclid's fifth assumption or postulate, or axiom. These are all interchangeable. This creates several new angles, which we'll label this way. I'm going to label the new angles located at point C as 4 and 5. If you observe, you have a pair of parallel lines in blue, and you have some angle relationships created. Let me go ahead and actually mark these lines as parallel. And you have a couple of angle relationships created among 1, 2, 3, 4, and 5. Observe that angle 1 is the alternate interior angle to angle 4. And because these lines are parallel, we can state that they are also congruent. So angle 1 is congruent to angle 4, and the reason for that is they are alternate interior angles. By a similar reasoning, we can observe that angle 2 is the alternate interior angle to angle 5. So angle 2 and angle 5 are alternate interior angles. Because these lines are parallel, those angles are congruent. Oops. Angle 5. And our reasoning there is this exact same reason, so I won't copy it. Up at up at point C, or angle C, we have a lot of things happening here. But one of the key things happening is that angle 4, angle 3, and angle 5 in total make this straight line, or this angle representing a straight line, which as we know is 180 degrees. So observe, statement 5, that angle 4 plus angle 3 plus angle 5 equals 180 because they make the line. This is a useful observation and a valid observation to make because our goal involves three things adding together to make 180, and that's precisely what we have here. Just the wrong three things, but it's a start. Notice that, using the highlighter here, that angle 1 and 4's equivalency allows them to be substituted. I can replace angle 4 with angle 1. By similar reasoning, I can replace angle 5 and angle 2. That's not a very good highlighter, is it? So that's exactly what I'm going to do. I'm going to, in purple, replace angle 4 with angle 1. I'm allowed to do this because of this. Plus angle 3, plus I'm going to replace angle 5 with angle 2 because of this. Let me keep that in green. Now it's camouflaged, you can't see it. Angle 1 plus angle 3 plus angle 2 as opposed to angle 4 plus angle 3 plus angle 5. I replaced 4 with 1, 5 with 2. My act of replacing there is called substitution. Substitution. And this is because of the commutative property. Order does not matter when you add. Because the commutative property, it is safe to say that 1, 3, and 2's equaling 180 is equivalent to what we want. Therefore, we have arrived at the end of our proof. So you make a pair of parallel lines using Euclid's fifth assumption that only one such pair exists. That creates alternate interior angles. You observe a linear pair, and then you substitute the alternate interior angles into the linear pair, or linear trio, I should say, to create our desired pair of 1, 2, and 3, or again, trio of 1, 2, and 3. Let's apply this principle. Here we have a complicated diagram with a couple of angles given and a couple of angles we need to look for. So let's find what we can. I see a triangle right here. We just proved that all three angles of a triangle make 180, so I know that these together make 180 degrees. So 180 is the total, and I already have 132 degrees if I add these together. So what remains must be angle 3. So 180 take away 132, using a calculator for efficiency's sake, will give me 48 degrees for angle 3. Not bad for a quick start. What else we got? We have that angle 100, or the 100-degree angle there, is vertical to this angle. So that means because vertical angles are congruent, that this is 100 degrees. That doesn't mean, let me redraw these, that doesn't mean that angle 1 and 2 are both 50. Maybe they are, but that would be an assumption to say that 1 and 2 are evenly split from that 100. Could be 80 and 20, could be 99 and 1 for all we know. So we can't make an assumption there. We don't need to. Observe that we have this large triangle here. If I draw that in isolation, what we have is 42, some unknown angle 4, and the 100 that we just marked. What do triangles make? As we just proved, 180 degrees in total. So from 180 degrees, I'm going to remove 142, the sum of these two, 180 minus 142. And this beautiful color is 38 degrees. Excuse me. So angle 4 is 38 degrees. Excuse me. It's that time of year. Because 142 and angle 4 make a triangle. Let's choose a more appealing color. Okay, well, we have a smaller triangle here. We just figured out angle 4, so with that in mind, if I draw that smaller triangle, I have angle 4, which is 38 degrees. This 93 was given, and this angle 2 is what we're still missing. So they make a triangle. So from 180, I'm going to remove the sum of 93 and 38. 93 and 38, once again using the calculator, is 131. 180, take away 131, leaves 49 degrees remaining. So this angle here, angle 2, is 49 degrees. Remember when I said it couldn't be 50, or it isn't necessarily 50, I should say? It isn't. And if angle 2 is 49, and 1 and 2 together make 100, then there's a couple of ways to find angle 1. I know that 100 take away 49 will give me 51 degrees for angle 1. So angle 1 is 51 degrees, and angle 2 is 49 degrees. There's actually one angle I didn't mark by mistake, making this at the end of the day, is right here, angle 5. Let's go ahead and find it just for, I hate to leave it hanging there. So angle 5 is the supplement of 93, so 180, take away 93 is 87 degrees. Using the triangle angle sum theorem, vertical angle, supplementary angles, and some angle addition. Hope this helps.